welcome back. In this video, we'll be looking at integrating x to some power, where that value of n may be an integer or maybe a fraction, and it could also be a negative value. But for most of the chapter, we deal with positive powers of x. Now, in differentiation, we learned about the power rule, okay? Yes, there was where you had to prove differentiation from first principles, but there is none of that in this chapter here. So we will just go ahead and we will learn how to undo what the power rule did for us in differentiation. So what happened in differentiation was that we took the function, we multiplied it by the power of x, and then we reduced the power of x by 1, and we got the gradient function. Now with the integration, we said we're going to do the reverse. That means we're going to start from the bottom of this ladder, where we got the gradient function. In first step to do that, so I'm just saying what we did when we had x to the power of 3, when we differentiated that with respect to x, was to bring the 3 forward in front, yeah, and then reduce the power by 1. Now we're going to take this 3x squared, alright, and the first step we need to do is the last step that we had here. It was reduction of power by 1, so we're going to add 1 to the power. Alright, the first step, don't forget, is first raise the power by 1 and then divide by the new power. Okay, not the old power, but the new power. So, and then that's it, you will get back the function you started with. So what I'm going to do is put an integral sign here and write dx, so that you know that I'm integrating this function with respect to x, right? And what I am going to do is have the x here. I'm going to leave a gap here at the front for the 3. Alright, so then adding 1 to the power is the first thing we're going to do. And then that would be a 3, right? And then we're going to divide. Here we multiplied, we brought the 3 and made it multiplication. So now we're going to divide by this new power here, which is 3. So what we end up with is these two 3's going to cancel away, and we get that x cubed back. Alright? So remember, here was the x cubed that we differentiated. Alright? And this was the result of differentiation, and this is lazy way of writing undifferentiated. Okay, you put the d here and you just put the whatever function you differentiated on top of this fraction, means undifferentiated. Here I differentiated x cubed, I got the result, and then I integrated that result here, and I got x cubed back with this rule. Okay, first add 1 to the power and then divide by a new power. It's fairly simple, but the trick is just to put a plus c here at the end. Alright, why did we put a plus c at the end? Because there could have been, alright, now in this case we didn't have anything. Actually, we could have differentiated x cubed plus 4 here. Alright, what if we differentiated x cubed plus 4? We would have still got 3x squared, right? The 4 would have dropped off, we would have dropped it off when we differentiated. So it could have been a million. It could have been 4 to the power of 5, who knows? When it disappeared, now that when we integrating that, we we don't know, there could have been a constant here. Like in this very first example, there wasn't, but there could have been, and it would have disappeared when we differentiated. So we compensate for the fact that we don't know that constant by adding a c here. Now later on, when we have more information, we can figure out what the value of c was. Okay, but just remember that after integration, just put a plus c for a constant. Obviously, c, if you don't know what it stands for, it stands for a constant. Constant means a value that doesn't have x in it. Okay, so that's the rule. Let's look at some more examples. All right. So let me wipe off my writing here. And here, for example, the derivative of 2x, x squared is 2x. The derivative of x squared plus 5 is 2x. X squared minus 7 has a derivative of 2x. All these constants are disappearing. You see here, they just drop off because they're constants. All right, and we don't know what it was. Therefore, when you integrate 2x, you end up with x squared. We put a c plus c in front of the answer, like, so that we just saying that we don't know what that constant was. We can figure it out later if you tell me what the original question was. All right, what give me a point on the curve, and we can calculate it from values of x and y. But for the time being, remember, so here when you integrate a rate, here is a rate. Okay, because it's the derivative, you can call derivatives a rate of change with respect to x in this case. So when you integrate that, you're going to get the original function back with the plus c. And this is the power rule that you can use. All right. Okay. So let's see some other examples. For example, when you integrating, uh, we want to know what was the original y. The original y is the integral of x to the power of 4 with respect to x, which is adding what's pause the video, have a go at it. What is it? First, we're going to add 1 to the power. A new power is 5, so we put 1 over 5 in front of that. We have to divide it. It's the same as putting 5 in the denominator. And we put a plus c at the end. We actually write it to the power of 5 rather than 4 plus 1. So a better way of writing is 1/5 x to the power of 5 plus c. Here, what you do is you do exactly the same thing. Y is integral of dy by dx, which is x to the power of minus 5 with respect to x. So first you add 1 to the power, the new power is going to be minus 4. So you're going to divide by minus 4 as well. Alright, and you put a plus c after it. That's it. So now here is another function. It has more than one term. Just like we applied the power rule one term at a time, you're going to apply the reverse power rule with one term at a time. So y will be integral of 6x plus 2x negative with a minus 3 power and 3x to the power of half. So what do we get? We put dx here. When dx is there, it means it applies to every term. Alright, so what is the new power of x? It will be 2, and dividing 6 by 2 is going to be 3. I'm just going to write 3. So what is the new power? When you add 1 to minus 3, it will be minus 2, and 2 over minus 2. Now you can tidy this up in the next line. I'm going to leave a gap here. Alright, maybe I can put a 3 here. What is the power, like adding 1 to 1 half? It's going to be 3 over 2. Now dividing by 3 over 2, it means that, don't, don't forget the plus c, so we can tidy the fractions up in a minute. So 3x squared doesn't change. This becomes simply a minus x to the power minus 2, and dividing by 3 over 2 is the same as multiplying by 2 over 3. So I could cross this 2 off and put the 2 on top of the fraction. And the 3 and the 3 will cancel away. So I will have simply a 2x to the power 3 over 2. And I won't forget the plus c, like so. Okay? So let's look at another example. In this example, we integrate in two terms. So first you're going to add 1 to the power of half, so you get x to the power of 3 over 2. But dividing by 3 over 2 is the same as multiplying by 2 over 3. So we'll have 3 over 2 here, but I'm going to write 2 over 3 at the front because 1 over 3 over 2 is equals to 2 over 3. And then I'll write x to the power of 4 here, and 2 divided by 4 is the same as a half. So, and I won't forget the plus c here. All right, so that's that.